Hello everyone, welcome to XSTEM All Access. I'm Samantha Hunsinger and I'm thrilled to be a part of this series showcasing some of the coolest minds in STEM. In this series, we'll dive deep into the diverse world of impactful STEM careers and the individuals leading the way in science, technology, engineering, and math. As your guest host for this episode, I'm so excited to chat with Mr. John Vickers from NASA. He's the principal technologist at NASA's Marshall Space Flight Center, where he serves as the steward of NASA's advanced manufacturing technical capabilities. You may be thinking, what does advanced manufacturing have to do with our nation's space agency? Well, the answer is a lot. Advanced manufacturing is actually a critical part of the cutting-edge work taking place at NASA that allows us to explore space and beyond. I hope you're ready to jump in to learn more about this important, high-tech, and innovative field that is in many ways manufacturing our future. Make sure you subscribe in the YouTube description below and follow us on social media to get updates on new XSTEM episodes. Check out the full collection of episodes available on demand right here. You'll find topics ranging from robotics to neuroscience, math to climate science, and everything in between. Plus, educators can access NGSS and CASEL-aligned lesson plans to accompany each episode, including today's. These lesson plans are written by educators for educators. Browse the entire library of free lesson plans here. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and me, at Sammy Hunsinger. First, let me tell you a little bit about myself. I've been a space nerd my whole life, loving everything above my head and watching rocket launches. I became a manufacturing engineer, working in the automotive industry, where I use my creativity every day to solve problems. And I'm also a student pilot, working to get my private pilot's license. Now, I hope you are as excited as I am to hear from our speaker, Mr. John Vickers of NASA. With over 35 years of experience in materials and manufacturing-related research and engineering, his work plays a critical role in NASA's mission success and the future of space exploration. We're going to learn how his job not only impacts NASA's important work, but also makes its way into other industries and ultimately all of our lives. John, welcome, and thank you for joining us today.
So hello, Sam, and hello to all the students that are listening today. This is a topic that's really important to me. It's important to my role at NASA. It's important to the nation, and it's something that I'm really excited and passionate about. So I'm very excited to be here today.
You are the Principal Technologist for Advanced Manufacturing at NASA's Space Technology Mission Directorate, which develops technologies and capabilities to enable a new class of NASA missions. In addition to offering solutions in space, these technologies and advancements also impact our lives here on Earth. Can you tell us more about how the space technology developed at NASA has real-world benefits for us all?
Sure, that's a great question. In fact, NASA produces a magazine, a publication called Spin-Offs. They do that to document NASA technologies, not just advanced manufacturing technologies, but across the board NASA technologies and how they can be spun off into industry sectors. And in fact, we have an entire organization at NASA, and it's called our Technology Transfer Organization. And their charter is to make sure we take our NASA technologies and we use them to the best of our ability in other industries. That's part of what NASA is about. I was lucky enough recently to participate on a White House report on space manufacturing technology, and within that report, the part of the purpose of that report was to make our country more competitive in this area, advanced manufacturing. And so we had identified some new technology areas. We call them emerging critical technologies, like additive manufacturing, robotics, digital transformation, high performance materials, and some others. And so it's those kinds of technology areas where we're working at the cutting edge. They're not technologies that industries are already advanced and is using. It's those kind of technologies where we're working at the cutting edge that are best suited for us to transfer to industry next.
How exciting that the emerging technologies being developed at NASA will make their way into our daily lives. I mean, robotics, 3D printing, high-performance materials. This sounds like science fiction coming to real life. Technological advancements in these cutting-edge areas can really transform our world. I personally can't wait to see what's next. If you want to dive deeper into the NASA-developed technologies that are now available to all of us, check out this page. There's even an interactive map where you can see what NASA technologies were created in your own home state. John, let's talk more about advanced manufacturing. For those students out there that may not be familiar with this industry, what exactly is advanced manufacturing?
On my drive in today, I thought about the conversation that we were going to have and observed the Home Depot, where all these products that they have at that home store, are manufactured products, or the Walmart are manufactured products. An auto supply store, or even I saw a paint store. All those things are manufactured by suppliers around the country. In fact, there are approximately 300,000 manufacturing factories in this country. Think about an automobile. A car today has about 30,000 parts in it, and all those parts are manufactured by suppliers. And if you go to an automobile factory, what they're doing really is assembly. They're taking all those parts that are manufactured all over the country. An airplane's a great example. One of the big airplanes that fly today, the new Boeing 787 aircraft, has approximately 3 million parts. Now, those come not from this country, not just from this country, but from all over the world. But think about that. 3 million parts have to come from factories all over the world. And that's those suppliers. And that's what really manufacturing is today, is all those companies, those factories all over this country and all over this world, some of them making finished products that you'll see at Walmart, some of them making parts that are going to wind up in an automobile or an aircraft.
And those companies are using high-tech processes like 3D printing, robotics, precision machining, and more to create those parts. I know, working as a manufacturing engineer in the automotive industry, the exact same applies to cars we all drive every day. Advanced manufacturing is what makes the high-tech cars and airplanes of today a reality, plus many other items that we rely on every single day. The next time you're in the car or traveling by plane, think about the millions of different parts that came together to make that possible, and how they were made, all thanks to advanced manufacturing. Now, when most people think of NASA, what typically comes to mind are astronauts, planets, and rocket launches. Advanced manufacturing is probably not something most people associate with our nation's space agency. Can you tell us why advanced manufacturing is important to NASA and its missions?
So I have about a 40-year career, and a lot of my career, because of the area that I work in at NASA, is in rocketry. So advanced manufacturing for rocketry. You're likely aware of the generations of launch vehicle spacecraft that we've produced at NASA. So the Apollo program that took us to the moon, the shuttle program was sort of the last generation. I worked in the shuttle program. And then today we have the Artemis mission, and that's the large NASA rocket that you might have seen on the news that's going to take us back to the moon.
Going back to the moon. Tell the lunar surface we gon' see you soon. 1972, the last time we were there. We gotta clear the air. There's still so much to discover. First woman on the moon, first person of color. Gonna make great history like no other. Collaboration will help along the way to help us have a longer lunar stay. Going back to the moon. We going back to the moon. Tell the lunar surface we gon' see you soon. We got NASA on a miss, you don't wanna miss this. We going back to the moon. Back to the moon. We going back to the moon. Tell the lunar surface we gon' see you soon. We got NASA on a miss, you don't wanna miss this. We going back to the moon. We going back to the moon.
There's some other programs that you're seeing in the news today. The International Space Station, that's a program that I worked on when I first came to NASA, It's been in orbit for more than 20 years, permanently occupied by humans for more than 20 years. But what I worked on was, if you see that space station, you see these cylindrical elements, and those are the habitats and the experimental modules, etc. So those are made from aluminum, and they're all welded. They're not mechanically or bolted, fastened together. They're all welded. So we were working on the welding. We in fact invented a new welding process um, for the International Space Station modules, and I'm in Huntsville, Alabama. They were all built in Huntsville, Alabama, and then launched into space. You've probably seen in the news the James Webb Space Telescope. That is a phenomenal space telescope, but it's something that was manufactured. The mirrors, there are I think there's 18 individual mirrors that make up the overall mirror. That's about 20 feet, 6 meters or so across. Those are made from beryllium. They're gold plated. It's just a tremendous effort to make those. They're incredibly precise. They're thermally dimensionally stable. They're all held in place by a composite structure. We really rewrote the book on thermal dimensionally stable composite structures because that's what was required for this James Webb Space Telescope. So there's these phenomenal rockets, rocket engines, launch spacecraft, the capsules that the astronauts. We're responsible for the manufacture of all of those spacecraft and scientific instruments. So a lot of pretty cool jobs at NASA in manufacturing.
Those are definitely cool jobs. If you're interested in building the rockets and spacecraft that take us into space, or the International Space Station that houses astronauts, or the innovative scientific tools and instruments that allow us to explore space and beyond, then advanced manufacturing may be a career field you should explore further. Speaking of innovative technologies, do the advanced manufacturing technologies developed by your team make an impact on the industries outside of NASA?
So our missions at NASA, if I can categorize them sort of simply, we have this rocket category, and that's our human exploration missions that we perform. Science, where there's all these science instruments. In fact, we have more than 100 active science projects where we're looking at the sun, the earth, the moon, the solar system, etc. And then we have our aeronautics mission where we're looking at making better aircraft. So how do those spin off or spill over into other industries? Take the defense. The defense industry is a good example because we have a lot of synergy with the defense industry. And so if you take their missions for, Army, Navy, Air Force, so land, sea, and air. If you look at the Navy, for example, they're making ships. They're manufacturing ships. Long ago, ships were manufactured. They were put together with rivets and fasteners, and they were not welded. Around World War II is when they started welding these ships, and just made a dramatic improvement on how fast they could make them. It used to take years, and it still takes a long time, but it used to take years to make. So the same kind of welding advances that we make at NASA can be utilized for defense in the Navy and for commercial shipping. Certainly the materials, I talked about composite materials just a minute ago, certainly the materials that we use for space, because they're much lighter and much stronger. Composite materials, for example, are finding their way into aircraft. The Boeing 787 aircraft is mostly composite. Most of your military aircraft today are composites. And so we work on those same kinds of areas.
So, advanced manufacturing is not only responsible for creating the products and machines that we rely on, and for building the equipment that allows NASA to explore space, but it also plays a role in the defense industry that keeps all of us safe. Advanced manufacturing really does impact our lives in every way. You mentioned advancements in welding. Many of us don't think about welding as high-tech, but improvements in technology have really transformed welding into a high-tech career field. Let's take a look. Wow! Who knew welding had so many STEM career path opportunities? John, can you tell us about the kind of advanced manufacturing jobs that someone would do at NASA?
Sure, there's a lot of exciting jobs in advanced manufacturing. It's been a tremendous career for me. But I mentioned earlier the missions that we have. So all of our advanced manufacturing jobs, or most of them anyway, are going to be related to those missions. So that human exploration where we're building rockets, or the science missions where we're building science instruments like the James Webb Space Telescope, or our aeronautics mission where we're trying to improve aircraft with, things like advanced materials. We're trying to make aircraft engines higher performance, more fuel efficient, quieter, those kinds of things. So our manufacturing engineers are contributing to that. A good example is additive manufacturing for propulsion system for liquid rocket engines. So if you look at these liquid rocket engines, these hugely powerful liquid rocket engines, they really take a long time. They're very complex, lots of parts in those. And the traditional way, we've been making those since the Apollo program for more than 50 years. And so the traditional way takes a really long time to make these rocket engines, and it costs an awful lot to make it. It costs too much, frankly, to make them using the traditional ways. 10 years ago, little over 10 years ago, nobody was using 3D printing, additive manufacturing. Those are the same thing. So I say additive manufacturing. Nobody was using additive manufacturing a little over 10 years ago to build rocket engines. They didn't really think that it was feasible, and so we began to do it. We thought it was feasible, and so we're trying to do that extraordinary thing. And so we began to use additive manufacturing, 3D printing, for liquid rocket engines. And today, nobody is not using 3D printing for their new liquid rocket engines. So that's just been a huge success story for us.
I know a lot of students out there have 3D printers at school or even at home. I know I have one. Check out what I made with mine. It was on my cap for graduation. How cool is that? It's really neat to think that the same technology is being used by NASA to build rocket engines. If you have fun creating with a 3D printer, you are already dipping your toes into advanced manufacturing, whether you know it or not. John mentioned a few advanced manufacturing career examples at NASA, but let's take a look at other examples in this very diverse field. John, let's say a high school student is planning their next steps and is interested in pursuing a career path in advanced manufacturing at NASA or anywhere else. What type of education or training should they obtain?
Where we're talking about advanced manufacturing, and so we're talking about advanced manufacturing and the technology associated with that, how we can become more competitive as a country. Every time we get together to work on how we advance technology for the country, we also talk about the workforce. We have to prepare the workforce simultaneously to go along with all these advanced technologies. I said earlier that advanced manufacturing is becoming more and more high tech. Over the next decade, actually maybe before the year 2030, studies have shown that there's going to be a requirement for more than 2 million advanced manufacturing jobs. And those are going to be at all levels. Those are at, I'll sort of characterize them as the technician level, where you might be doing machining or welding, some of the things that I've talked about before. This is still high-tech work. If you look at machining or welding today, it's done with robotics, computer-controlled machines. And so there's some level of what we call this STEM training, science, technology, engineering, and mathematics, that's required. But that doesn't mean that it requires a 4-year college education or even further, an engineering degree. You can get that at a community college. There's a lot of community colleges today. There's all kinds of programs at community colleges, even some of these programs at high schools for what I'm calling this technician level. By the way, those are great jobs. They're exciting jobs. They're not dirty and dangerous jobs like some people have the perception of those advanced manufacturing. They're very clean. They're robotic. They're computer controlled. But if you want to go on beyond that, a 4-year education in engineering, mechanical engineering, industrial engineering, materials engineering, aerospace engineering, all of those engineering degrees will help you in your, in an advanced manufacturing field, even business. We need business leaders that come from the advanced manufacturing world. And I'll give you an example. The richest person, or maybe the richest person in the world today, is Elon Musk. Two of his two biggest companies, Tesla, where he makes electric cars, electric vehicles. That's a manufacturing company that he has. And then SpaceX, his space launch business, that's a rocket manufacturing company. And I've heard him say about that advanced manufacturing is the key part of that business. It's not the design, it's not those other things. Advanced manufacturing is the fundamental part of those business. Now you can go on in your education and become, with advanced degrees, PhD researchers in all kinds of areas that support advanced manufacturing. That's a great thing about advanced manufacturing. It has occupations at really all levels, and they're all. I work with all of those people, the business people too, and it's all tremendously exciting and rewarding work.
There really is something for everyone in advanced manufacturing. And with 2 million jobs needing to be filled in the near future, these are high-tech jobs that are in demand. Before we end our conversation, let's talk about the future of the industry. Do you foresee any major breakthroughs or new innovations on the advanced manufacturing horizon?
I think over recent times, this last decade or so, the technology that we're working with in advanced manufacturing has just accelerated tremendously. And a lot of it is in these emerging areas that I talked about earlier: additive manufacturing, 3D printing, advanced robotics, high performance materials. I think in the next decade, we're going to see another tenfold in technology advancement in advanced manufacturing and a lot of other areas too. But really advanced manufacturing is where these technologies. I mean, we're building we're building things, and so where we're building products, that's where you really see the impact. So I see a lot of. It's becoming more and more high tech, more and more, and it's not going to slow down. It's going to speed up.
Personally, I can't wait to see what the future holds. John, thank you for joining us today.
Thank you, Sam, and thank you all the students for listening. I really enjoyed talking with you today. This is an area that I mentioned that I'm really excited, I'm really passionate about, and so I hope that came through. I hope you had some fun. I think there's a really bright future in this country as well as others for advanced manufacturing. So if I can help in any way in the future, Sam, you guys let me know. Thanks again.
I share your passion and enthusiasm for manufacturing and space exploration. I really enjoyed learning about the field of advanced manufacturing in space and how it impacts all of us in so many ways, from creating the next generation of vehicles to rockets capable of sending humans to the moon, and even building the ships and aircraft used by our military to keep us safe. For any students out there looking for an in-demand, high-tech career path that impacts the world, advanced manufacturing is definitely worth looking into. Thank you for tuning in today. Make sure you subscribe to the YouTube channel in the description and follow us on social media to get updates about new episodes. You won't want to miss them. Plus, you'll get access to fun weekly content for students and teachers, such as STEM facts for students, classroom tips for teachers, and so much more. And don't forget to check out the full library of episodes available on demand right here. Each one has an NGSS and CAST-aligned lesson plan for teachers to use in the classroom. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and me at Sammy Hunsinger. And keep up with me and all things space through social media here, where I share my excitement for NASA and space exploration and my experiences as a manufacturing engineer. I had a blast being your host today, but don't sign off just yet. You'll want to stick around through the end of this video for a fun trivia game that you can do in the classroom or at home. Have fun and good luck.